What is up, guys? Today we are going to talk about latitude and, more importantly, longitude. So the first question you might have is, what is longitude and what is latitude? Well, latitude, basically, it's naturally set. 0 degrees latitude is at the equator. Longitude, 0 degrees can be right here, it can be right there, it can be out there. However, now it's set in Greenwich, England, but back then, it could be set whenever you wanted it. Stop. So you might be wondering, why is it important to know your latitude and your longitude? Well, because out there, you can get lost. If you look out there, there's only one way to figure out where you are, unless you remember very specific locations. Like if you can see it, that island off in the distance. Basically, your latitude is your horizontal line, so it's gonna go like this, and your longitude is your vertical line, it's gonna go like this. If you can figure out both, you can get a crosshair, and in the middle of the crosshair, that's where you are. But sailors back in the 1700s and before couldn't figure out their longitude. They could figure out their latitude with devices such as the 9th century Arab-made Kemal, which we're going to go over later tonight when it's darker out because we're going to need the North Star. But longitude, no one could figure it out. And that resulted in boat crashes, which then resulted in the loss of lives and the loss of goods. So longitude, if you're wondering, it's divided into 360 degrees to cover the whole Earth. And it's divided by the 24 hours of the day. So each longitude line is 15 degrees, and each 15-degree line represents 1 hour. So if you're off by just 10 degrees, you're off by almost an hour. And the difference in miles between longitude, if you're over there versus over there, there could be rocks in the middle of that. So if you're off by just a little in your longitude calculation, that's the difference between getting to shore or running into rocks and having a lot more problems. And some of the problems, as discussed in the book Longitude, which you should read, we start with the Cloudesley fleet, and General Cloudesley was sailing and he screwed up his longitude, so he didn't know where he was. The problem is he ran ashore, the boat was destroyed. Now one of his sailors actually told him, "Sir, you're messing this up, this isn't right." Now that sailor boy was correct, and for being correct, he got hung on the spot. And the reason he got hung on the spot is because he questioned his captain, which you cannot do. You can't question the captain. So even though he was correct, he got hung for being correct. And in an ironic ending, Sir Cloudesley washed up on a beach, and a woman found him, and she was distressed because she didn't know if he was okay. But he had a ring on his finger, so once she saw the ring, she beat him, killed him, and took the ring. Another issue that was explained in the book was the Centurion fleet. So the Centurion fleet was sailing to the South Pacific in September 1748. However, because their captain didn't know the longitude, he ended up zigzagging all around like this while his men died of scurvy. He didn't know where he was, so he was just going back and forth. He thinks, it's over here. No, wait, it's over there. And he just zigzagged back and forth for months. And then eventually he decided he wanted to go to Juan Fernandez Island, which had fresh water for his dying men. However, he zigzagged for 2 weeks trying to find it, and in that span, 80 more sailors died. Alright, so as I mentioned before, we have here an early Middle Ages device, and it's made by the Arabs. It's called the Kemal. And basically you can use it to find your latitude. Again, we're going to come back at night to demonstrate this, but I want to show it off during the day while we have a lot of light. So what you're going to want to do is you take a piece of cardboard or really anything that's a square, put a hole through it, tie off one end of a rope, and string the rope through the Kemal so you have something like this. That way it doesn't come out. And then what you're going to want to do is you hold it, you have to shut one eye to do this. So you're going to want to hold it like this, and I'm not facing anything in particular because we don't have the North Star right now. That's why we're going to come back at night. But basically you want the bottom of your Kemal to be on the horizon, and you want the top of your Kemal to be lining up with the North Star. And by doing that, you can actually find your latitude. And it's impressive to see because from right here I have my latitude if I had the North Star. But even one step forward, I'd have to recalculate everything. So that just shows how precise your latitude needs to be with using the Kemal. But obviously there were flaws with it. You had to have a North Star or another fixed star, and I can't do it during the day because I don't have a fixed star. So it wasn't perfect, but for the 9th century, which is the early dawn of the Middle Ages, it was pretty good. But later devices like the sextant came out later. So I went back to the beach like I said I was going to, but because of the weather we've been having here in Connecticut, there hasn't been any stars. The whole sky has just been cloudy. So unfortunately, I waited until the last second that I could to try to demonstrate how to use the Middle Ages Kemal. But unfortunately, I still can't because, as you probably can't tell, there is still no stars in the sky. And as we went over before, you need a star to focus your Kemal on. So I'll try to demonstrate it, but I can't really do too much because I don't have a star. But unfortunately, with the hurricane that might be coming, we've had a ton of rain. So the night sky has a lot of clouds, so I can't really do what I want it to do. So basically what you're going to want to do is, again, imagine there was stars to do this with. You just take the string here on the Kemal. It's just a string through a piece of cardboard or really any square surface that you can get a hole through. So you just take it like this, pull it up to your eye, close one eye, line the Kemal up with the horizon. The bottom needs to be on the horizon and the top needs to be towards the North Star. And make sure the strings are around your mouth. And then from that, if I had the star to focus on, I could find my latitude. But again, I don't have the star, so I can't find it. But that is the gist of how you use a Kemal. Because finding longitude was the problem of the day, as we already talked about with some of the problems that happened because you couldn't find your longitude, again, the difference in longitude could mean getting to shore or crashing on a rock and everybody dying. So the Longitude Board, which was established in the 1700s, and the Astronomers Royal offered a 20,000-pound prize to whoever could find longitude within half a degree. And now even a half a degree is a little bit of distance, but it's not that much considering no one could find their longitude and know where they were. So this is where John Harrison, the famous clockmaker, comes in. He was the one who invented the clock that was able to keep longitude very accurately. Now, other people decided to get in on the prize running too, with crazy ideas such as the powder of sympathy. So the powder of sympathy is probably the craziest idea that these guys had to find longitude. So the idea was there was this powder, and the theory is if you apply the powder to a bandage and put it on a wound, the wound will heal, but it will hurt like hell. So the idea was to send a wounded dog on a ship, and then every day a trusted individual back in England would dip the bandage in the powder and hoping that the dog would yelp. So if at noon they dip the bandage in the powder, and then say at 1:30 the dog yelps, the theory is you could find your longitude that way. Obviously the powder doesn't work, and there's no way it's gonna work if someone dips a bandage in England versus if the dog is in the South Pacific. It's not gonna work. And the worst part was, the dog sometimes had to be re-injured if the wound healed naturally. So that's one of the craziest theories of people trying to win the 20,000. So what Harrison really discovered was that he could make his clocks so that when the boats were shaking, the pendulum didn't get thrown off too much. He also realized that he could make sure his clocks, when wound, they didn't run too fast and then slow down. That was the problem with ship clocks, is at the end of the day and the beginning of the day, it runs faster when you first wind it, and then when it's pretty much unwound, it runs slower. Harrison's clocks were able to defeat that, and because of that, he was only off by a couple seconds on his voyages, proving that his clocks were the best clocks to determine longitude at sea. So again, Harrison spent his entire life devoted to these clocks and making them. H2 to H3 took him an entire 19 years. That's an extremely long time to be working on one single thing. But the Longitude Board was paying for him to do this as he went, so he was still working and making money while he was getting the clocks done. But what Harrison did, we really can't quantify, because the amount of lives he saved by developing a method of finding longitude at sea made it so sailors could sail, and they might not have the troubles they had before if they could use it accurately. They could avoid the rocks, and they could avoid other possible hazards at sea, and it opened up the sea and the world to exploration. Now that we can figure out your longitude and your latitude, you can figure out exactly where you are, which made exploration of the sea much more possible. Now, if like 100 ships, say, just 100 or 1,000 even, fell to shipwrecks from rocks from not knowing their longitude, it would come down to 10 or 1, because most ships had capable captains and they could find their longitude, so they could avoid the rocks and they could avoid other things that could derail their entire cruise. So everyone, I hope you learned a thing or two about why finding longitude is so important, as we went over with the Cloudesley fleet. I hope you learned why Harrison was such a crucial figure as he developed an accurate method of keeping longitude at sea. We really can't count how many lives he saved because of his methods. You know, if the sailors did not have his methods, who knows how many people could have died at sea. We really can't count that. So I hope you learned today why longitude is so important and why Harrison's such an important figure in finding it.